So in today's lecture of ordinary differential equation, today's topic will be linear dependence and independence. Okay, let me start. Now see this linear dependence. Now what is a linear dependence? Two functions phi1, phi2 defined on an interval I are said to be linearly dependent on I if there exist two constants c1, c2 not both 0, such that c1 into phi1 of x plus c2 into phi2 of x is equal to 0 for all x in I. Okay. Next, let me give you all the definition of linear independence. Now, what is a linear independence? The function phi1, phi2 are said to be linearly independent. Now, this function is said to be linearly independent. So, now this function is said to be linearly independent on I if they are not linearly dependent there. Okay, if it is not linearly dependent, that means it is a linearly independent, right? So take the actual definition over here. Linear independence: two functions phi1, phi2 are said to be linearly independent on I if the only constant c1, c2 such that c1 into phi1 of x plus c2 into phi2 of x is equal to 0 for all x in I. The constants c1 is equal to 0 and c2 is equal to 0. For linear independent, the constant both will be equal to 0, right? Now let me prove one important result. If the solution phi1 and phi2 are linearly independent, where phi1 of x is equal to e raised to power of r1 of x, phi2 of x is equal to e raised to power of r2 of x, okay? Now take this c1 into phi1 of x plus c2 into phi2 of x is equal to 0. From where I have taken this? From here, okay, this part. Now therefore c1, now what is my phi1 of x here? E raised to power of r1 of x, right? Plus, write this c2 as it is. Now what is my phi2 of x is nothing but e raised to power of r2 of x, write it here. Now which is equal to 0, and take this as equation 1, okay, take this as 1. Now next is what? Now multiplying equation 1 by now I will be multiplying this equation 1 by e raised to power of minus r1 of x. So I will be multiplying e raised to power of minus r1 of x on both the side of this equation, okay? So what I will get is c1 into e raised to power of r1 of x into this. I am multiplying, no? E raised to power of minus r1 of x plus c2 e raised to power of r2 of x into e raised to power of minus r1 of x is equal to 0 into e raised to power of minus r1 of x, okay? Now e raised to power of r1 of x minus r1 of x will be what? It will be 0, right? So that's what I have done, e raised to power of 0. So c1 into e raised to power of 0 plus c2, write it as it is. Now x is common for both. So write r2 minus r1, e raised to power of r2 minus r1 in the bracket into x, this. Now this is equal to 0 because if you multiply anything with 0, it will be 0. Now this is what e raised to power of 0. We know that e raised to power of 0 is equal to 1, okay? Oops. Write down c1 here by mistake. Okay, so c1 e raised to power of this thing. So what will remain? c1 will remain over here plus c2 e raised to power of this, write it as it is, okay, is equal to 0, and take this as 2. Next is what? Now by differentiating 2, now I will be differentiating this equation. So what I will get? This will be 0, right? So write down 0 plus c2, then e raised to power of r2 minus r1. This will be coming forward, right? Into e raised to power of this I have to write down. So c2 into r2 minus r1 into this e raised to power of r2 minus r1 into x, okay, is equal to 0. Next is what? Therefore So C2 into R2 minus R1. This write it as it is. E raised to power of R2 minus R1 into X is equal to 0. Now this the entire equation is equal to 0. Now this implies what? That C2 is equal to 0. Because here R1 is not equal to R2. Comma this R2 minus R1 is not equal to 0. Okay. And okay, now what I put is C2 is equal to 0 in equation 2 or in 2. Okay, put this in this 2. Where is it? Over here, right? So if you put this, if the value of C2 is equal to 0, then what it will imply? C1 is equal to 0. Okay, so that's what I have done. I wrote here. This implies C1 is equal to 0. Therefore, C1 is equal to 0, comma C2 is equal to 0. Hence proved. So it is linearly independent, right? Those solutions. Now second one is what? If R1 is equal to R2, then the two solution, that is phi 1 of x is equal to e raised to power of R1 of x, and phi 2 of x is equal to x into e raised to power of R2 of x. Therefore, phi of x is equal to C1 phi 1 of x plus C2 phi 2 of x is equal to 0. This you all have to take down. Then what is it? Now what is my C1? Write it as it is. Now what is my phi 1 of x? E raised to power of R1 of x. Okay. Plus C2, write as it is. Then what is my phi 2 of x? X into e raised to power of R2 of x is equal to 0. Okay, just put that is equal to 0 over here. Is equal to 0. Okay, here. Now C1 plus C2 of x. Now C1 plus C2. E raised to power of R1 of x is common for both. Okay, is equal to 0, and take this as 1, equation 1. Okay, now multiply on both the side by e raised to power of minus R1 of x. Okay, both the side of this equation 1. So C1 plus C2 is equal to 0. If I multiply this on both the side, what I will get? Finally, I will get C1 plus C2 into x is equal to 0, and take this as 2. Okay. Next is what? Differentiate this with respect to x. I have to differentiate with this respect to x. So what I will get is, now this is nothing but 0 plus C2 is equal to 0, which implies nothing but C2 is equal to 0, right? So C2 is equal to 0. 0 plus C2 is equal to 0 I am getting. Therefore 0 is equal to 2. Now put this in 2. So if I put this in this equation 2, that C2 is equal to 0, what it will imply? That this C1 is equal to 0. So C1 is equal to 0. Therefore C1 is equal to 0, comma C2 is equal to 0. Now this proves that if the solution are linearly independent, then C1 is equal to 0, comma C2 is equal to 0. So with this I will end up my lecture. I hope you all have understood my today's lecture. If you all have not understood any of the concept of today's, you all can comment below, and thanks for watching.